All right, today we're going to dig deep, and I mean that literally. We're diving into the story of coal and petroleum. And look, this isn't just about some rocks and a bunch of black goo. This is the story of ancient, buried energy and inheritance that basically built the entire modern world and powers, well, pretty much everything we do. So let's get into it. It's a great question, isn't it? And it sounds kind of like a riddle. But believe it or not, the answer creates a direct line from the screen you're looking at right now all the way back to a world of prehistoric swamps that existed hundreds of millions of years ago. And that answer, at the very heart of it all, is fossil fuels. It's this incredible inheritance of buried energy, cooked and compressed over an insane amount of time that became the engine for our entire industrial civilization. Okay, so to really wrap our heads around the story of coal and oil, we first got to zoom out and look at the bigger picture. We need to talk about natural resources in general and, where these fuels actually fit in. So fundamentally, you can pretty much split all natural resources into two big buckets. In one bucket, you've got the inexhaustible or renewable stuff. Think about sunlight or wind, right? You can use all the sun you want today. It's going to come back tomorrow. But then there's the other bucket, exhaustible, non-renewable resources. And this is where our story gets complicated, because this stuff is finite. Once you use it, it is gone for a very, very long time. And this is exactly why we call them fossil fuels. It's not just a cool name. They are the literal concentrated remains of ancient life. So we're not just digging up a substance from the ground. We're actually tapping into a legacy of past life that's been transformed into this incredibly potent energy source. Let's start with the first titan of the industrial age, coal. This solid black rock is, and this is a cool way to think about it, essentially ancient buried sunshine. Seriously, it's millions of years of solar energy captured by plants, all squished down into this one rock. And it's a story that begins in a world that looked nothing like ours. So I want you to picture this. Go back in your mind about 300 million years. Geologists call this the Carboniferous period. Earth was covered in these huge, steamy swamps and incredibly dense forests. And when all those massive plants and trees died, they just fell into the water. But instead of rotting away completely, they got buried, layer after layer of sand and mud piling on top. Now, this whole transformation has a scientific name. It's called coalification. As all that dead plant stuff got buried deeper and deeper, the immense pressure from above and the heat coming up from the Earth's core essentially cooked it. It's like a giant slow-motion pressure cooker that, over millions of years, turned all that soggy plant matter into hard, black coal. And as you can see, this whole thing happens in stages. It doesn't just happen all at once. It starts out as this soft, spongy stuff called peat. Give it more time and more pressure, and it becomes lignite, which is a kind of brown coal. Even more pressure turns that into the bituminous coal we see all the time. And then finally, under the most extreme conditions, you get anthracite, the hardest, purest form. And a quick tip to remember the order is, please let bitu attend. With every single step, it packs in more carbon, which means more energy. Okay, so that was the story from the swamp. Now, let's shift over to the sea and talk about coal's liquid cousin. It's a substance so valuable to our world that it's earned the nickname black gold. Yeah, we're talking about petroleum. So, unlike coal, which came from these massive forests on land, petroleum's story begins in the ancient oceans. Millions and millions of years ago, tiny little marine organisms, things like plankton and algae, died and just sank to the bottom of the sea. And just like the forests, they got buried under layers and layers of sediment before they could totally decompose. So, trapped down there with all that heat and pressure, their organic remains were transformed into crude oil and natural gas. And because they all have different densities, they naturally separate into these layers. You can see the gas, since it's the lightest, rises to the top. The oil hangs out in the middle, and water, which is the heaviest, sinks to the bottom. This layering is exactly what engineers are looking for when they drill for oil. Okay, so how do we get useful stuff out of raw coal and crude oil? Well, it takes two totally different processes. For coal, you use what's called destructive distillation. You're basically just heating it like crazy without any air to break it down. But for petroleum, the magic happens with something called fractional distillation, which is a much more elegant way of separating things. So how does this fractional distillation work? Well, it all goes down inside one of these things, a fractionating tower. First, you superheat the crude oil in a furnace until it all turns into a vapor. Then you pipe that hot gas into the bottom of this big tower. As the gas rises, it starts to cool down. And here's the key part.
Different parts of the oil, the different fractions, condense back into a liquid at different temperatures. So they get collected on these trays at all the different levels. Pretty clever, right?
And the result is, well, it's just incredible. I mean, look at this. From that one raw material, that one black sludge, we get this huge variety of products. Way up at the top, where it's coolest, you get petroleum gases, like LPG for your barbecue. A little lower, you get petrol for cars. Then kerosene for jets, diesel for trucks, and all the way at the bottom, the thick gunk that's left over is used for things like lubricating oils and the asphalt that paves our roads. But here's the thing. These ancient resources do way more than just get burned for fuel. They're actually transformed into the very building blocks of our daily lives, often in ways we don't even think about. And this is where it gets truly mind-boggling. The chemicals we get from petroleum, what we call petrochemicals, are used to make an unbelievable range of stuff. We're talking detergents, synthetic fibers like polyester for our clothes, pretty much every kind of plastic you can imagine, fertilizers to grow our food, even parts of medicines, cosmetics, and paints. Our reliance goes so much farther than just the gas tank. But, and you knew there was a but coming, this incredible power, this amazing versatility, it all comes with a serious cost. This ancient inheritance has some really unsettling consequences that we are dealing with right now, today. So here's the fundamental trade-off. When we burn fossil fuels, we release their incredible energy, but we also release a bunch of harmful byproducts into our atmosphere. This is a huge source of air pollution, and it leads directly to problems like acid rain and contributes to serious respiratory diseases all over the world. And as you can see pretty clearly on this chart, not all fossil fuels are created equal when it comes to pollution. Coal is by far the worst offender. Petrol and diesel are better, but they still pollute a lot. And this is why you hear so much about a push towards things like compressed natural gas, or CNG. It's still a fossil fuel, but as you can see, its emissions are way lower, making it a cleaner, though still not a perfect, option. And beyond the pollution, there's the other big problem: scarcity. Remember, these are exhaustible resources, and some estimates like this one for India's reserves are pretty jarring. If things don't change, known petroleum reserves could be used up in just a couple of decades. The clock is definitely ticking on our inheritance, which leaves us with this final, massive question. Our entire civilization, everything we know, was built on this foundation of ancient, concentrated energy. We've seen its incredible power, but we've also seen its profound consequences. So, knowing everything we know now, the great challenge of our time is to figure out what's going to build and what's going to power our future.